Okay. Now at this point, let us turn our attention to the analysis of the steady state error performance of non-unity feedback system. Okay. So mas madalas is actually ang mas realistic sa mga design ng control system is that there would always be a non-unity feedback. Ibig sabihin yung we studied unity feedback systems for in the interest of analyzing performance of para mas mapadali natin yung analysis natin. But in reality or in more practical sense, um most control systems do not have unity feedback dahil madalas ginagamit din yung feedback as a form of compensation or as a form of way as a way to actually design or to achieve yung objectives ng design niyo. Okay, so naglalagay tayo usually ng device doon sa feedback natin. Okay, so mas madalas we have to deal with non-unity feedback system. Okay. And in that case, let's say we have this general feedback system, okay, in which meron kayong G2 dito which may be composed of of a cascade ng plant ng controller tsaka ng plant. Okay, tapos meron kang input transducer tsaka may output transducer ka. Okay, so what we will do is we will move this summing point dun sa RS ninyo. Kasi kailangan natin yung ES eh. Okay, and by the way, kapag ganito yung configuration natin, more or less yung R ninyo, yung input ninyo tsaka yung output ninyo has different units. Therefore, itong difference nung converted signals nung R at saka C natin, okay, is what we call an actuating signal. Okay? So, gagawin muna natin is that we will express this in terms of we will define yung error performance nito in terms of the error signal, ES. Pero we will work under the assumption that C, yung output ninyo, at saka yung 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 input ninyo, RS, have the same or are essentially the same quantity. Okay, and therefore they have the same or they possess the same units. Okay, or dimensions. Okay? So, yun yung una natin gagawin. Okay? Second, we will generalize the case kapag ka yung CS niyo at saka yung RS niyo is not the same. Okay? So, kapag ka they represent different quantities. They should have been quantities din pala. Okay, so if they represent different quantities and therefore would possess different units or different dimensions, then we will treat this as the actuating signal. Okay, yung subscript 1 na to, okay, implies na meron kang G1 dito. Okay, kapag wala tong subscript, it means wala kang unit yung yung input transducer mo. Okay, so mamaya makikita natin sa mga examples. So as I was saying kanina, para ma-express muna natin siya in terms of ES, okay? So that we should assume na yung R at saka C ninyo have the same dimensions. We'll have to move this block, this summing junction papunta dito. Okay? So that ang mangyayari is that magiging ang system nyo, okay, becomes something like ito yung magiging G1 ninyo. Okay? Tapos ito yung magiging G2. Okay? Then this would be your C. Okay? Tapos yung sa feedback ninyo, okay, you would have H1 here. Tapos dahil nga sa movement na ginawa ninyo, magkakaroon kayo ng additional block dito, which is 1 over G1. Yeah. Okay. So dahil yun yung tinalunan nung inyong summing junction. Okay. So this is ito na nga yung bagong location ng summing junction nyo. This is negative, positive, and this is your R. Okay. So kaya ngayon i-assign natin to as EA1. Okay, itong signal na to. Okay, dahil nga may pinanggalingan to na G1 before. Okay. So that we can equivalently say na magiging ganito yung system niyo. Okay? Given that your G is basically G1 times G2. Tapos yung H ninyo is basically H1 over G1. Okay? So, remember this, equivalence. Okay? Pagka nag-translate na tayo dito. Okay. Now, so what will happen is, that, yung ating, ito, okay? Lalagyan natin siya ng, negative, ng feedback na negative 1. Okay? Tapos, meron tayong ilalagay pa na panibagong system or panibagong feedback na ang forward gain ay positive 1. Okay? So, ang gagawin kasi natin is i-reduce natin ito. Okay, i-reduce natin ito sa equivalent unity feedback system. Tapos, aalamin natin yung forward transfer function. Okay? So, in this case, as we explained dun sa chapter 4, okay, sa reduction ng systems, para ang isang system ma-reduce nyo sa unity feedback system, what you can do is you introduce these two feedbacks. Tapos, bali in this case, what we will have to do is to reduce this as a parallel system. Okay, ito. So that should become H minus 1. Okay, tapos itong parallel system na to, i-feedback natin sa G of S para maging single system itong tatlong ito. Okay, kailangan maging single system yan. Okay, so that what will happen is meron kang single system tapos meron kang feedback. Okay, na negative. Okay, so ito na yun. Nung nireduce nyo yung ito into parallel system, yun, nakuha nyo yung H minus 1. Okay, and then using the feedback formula, i-reduce natin itong dalawang ito sa feedback system. So you would have this. Okay, so yung if we assume that CS and RS have the same units, okay, what we will have is so yung CS natin tsaka yung RS natin have the same units. Okay, what we will have is an error signal, E of S. Okay, tapos ito yung magiging forward transfer function niya. So babalik tayo dun sa methods na diniscuss natin in the previous sections, okay, in the previous articles. Okay, so kaya lang yung ating forward transfer function would have then to be computed first. Okay? Para mailagay natin siya dito. Okay, so magsisimula again ang mangyayari is that magsisimula tayo dito. Okay? And then using this two equivalence formula, gagamitin natin itong formula na to. Okay, para ma-analyze yung error niya. Okay, so again, pagkaalam na natin itong forward transfer function na to, and assuming again that CS and RS are the same, ma-analyze natin itong ES or yung error signal niyo by identifying yung system type based dito. Okay? And at the same time, using the appropriate static error constant for that system type, and therefore computing the error for the appropriate input. Okay? So, ayun. So, notice that unlike a unity feedback system where you have 1 as your feedback, okay, the error is not simply the difference between the input and the output. Okay? For this case, we call the signal at the output of the summing junction the actuating signal. Okay? Pero that would be the case kung magkaiba yung units again ng C at saka ng R. Okay? Pero kapag yung ating R at saka yung C have the same units, okay, we can still find the steady state error. Okay? But we have to explicitly show, okay, that E is R minus C. Okay? By reducing your block diagram to this form first. Okay? So, yun yung gagawin natin kapag meron tayong non-unity feedback system. We have to reduce the system first into this form, okay, para ma-analyze natin yung steady state error niya. Okay. Now, let us take a look at example 6.12 wherein we would like to find the system type, okay, static error constant, and the steady state error for the unit step input. Okay? Now, importante dito is itong assumption na to. Okay? Kasi kapag hindi ito yung assumption, we might treat this problem differently. Almost the same, kaya lang yung interpretation ng error. It might be interpreted differently. Okay? So, In this case, since we will assume that the input and output have the same dimensions and therefore of the same quantity, we can compute this as the error itself, as the error signal itself, not the activating signal kasi nga pareho naman tong R at saka C. Okay. So what we will do then is we will reduce this, okay? We will reduce the system, okay, into a unity feedback system. Okay. So kailangan nating mahanap yung G. This is based sa ito, figure 6.7e. Okay. So this is G, and then ito unity feedback system na siya. So 1 na to. Okay. So this is negative, positive. This is your R. This is your C. Okay. So hanapin natin itong open loop transfer function na to. Okay. O yung equivalent transfer function na to. Label natin GE. Ano bang ginamit niya dito? Wala siyang ginamit. Pero yung GE ito, basically ito yun. Okay. Ito yung equivalent ng unity feedback system. Equivalent forward transfer function ng unity feedback system. So let's use GE for that. Okay. And then we compute now GE. Okay. We compute now GE. Okay. As G. Okay. Over. Ito yung G ninyo. This is your H. Okay. G over 1 minus 1 plus GH minus G. Okay? Now, again, tatandaan natin kapag meron kang input transducer, okay, yung G ninyo, okay, is basically yung yung transfer function ng input transducer times itong forward transfer function. Okay? So, again, we remember na kapag meron kayong input transducer, okay, pag meron kayong input transducer dito, okay, you have to multiply the transfer function of that input transducer dito. Tapos you have to divide that dito sa feedback. Okay, pero since wala naman tayong input, meron ang input transducer natin as a unity transfer function, then we can simply have this as G and your H. Okay, so we substitute this transfer function into your formula. Okay, so we will have 100, okay, over let's use this area. Okay, so we will have 100 over S times S plus 10, okay, all over 1 plus 100 times 1 is 100 over S times S plus 5 times S plus 10. Okay? Minus 100 over S plus 10. Okay? Now, para mas simplify niyo yung mas simplify natin yung pag-evaluate ng ganitong complex fraction. Let's simply, kasi ang magiging LCD dapat nito is S times S plus 5 times S plus 10. So para mas madali natin siya ma-cancel, ilagay din natin siya dito. So, dagdagan natin ito ng factor na S plus 5. Siyempre, dadagdagan ko rin yung taas niya. Okay. Ito rin, para pareho na sila. Dadagdagan ko itong factor na X, S at saka S plus 5. So, idadagdag ko rin siya dito. S times S plus 5. Okay. So, ayan. Now, again, ito na yung magiging LCD ninyo. Okay. Which would cancel this numerator. Okay. So, you would be having the equivalent transfer function as we will have the equivalent transfer function, okay, as this should be equal to yung numerator nyo is simply 100, okay, over S plus 5 na. Yan na yung magiging numerator nyo. Divided by, okay, so ito, mamultiply dito, so this becomes S times S plus 5 times S plus 10, okay, plus 100, okay, minus 100 times S plus 5. Okay, so yan yung magiging denominator ninyo. Now, if you multiply this out and then express this as a polynomial, you would be obtaining something like this one. So, magiging S cube plus 15S square minus 50S minus 400. Okay, so, again, this denominator, okay, this whole thing becomes this one. Yan, magiging ganyan siya. Okay. So, please check that out para, para mas, natin, ma-verify natin. Okay. Pero what would happen is that, lalabas ngayon, ito na ngayon yung magiging GE ninyo. Okay. So from there, since na-reduce na natin siya into a unity feedback system, okay, we can now see na, na ang system ninyo ay type 0. Okay. Type 0 yung system ninyo. Okay. Whereas, baka kasi pag titingin nyo dito at tingnan nyo yung forward transfer function niyo, baka bigla kayo mag-conclude na type 1 siya because of this integration factor. Which is wrong kasi meron pa siyang feedback. We have to consider that feedback. Okay? So, in that case, we have to reduce this into a unity feedback system. And reducing this to unity feedback system reveals na ito ay yung equivalent transfer function nyo and that your system is type 0. Okay? So, tingnan natin mabuti yun pagka we're dealing with a general system. Okay. Now, since this is type 0, okay, the appropriate static error constant for this is Kp. Okay. So, ang magiging tamang static error constant na i-compute natin is Kp. Okay. Which is the limit of this entire thing as S approaches 0. Okay. So, which is clearly 100 times 5 divided by negative 400. Okay. Kasi magsi-0 naman na ito eh. So, 100 times 5 tapos 0, 0, 0. So, may iwan dyan is negative 400. Okay, so which gives us an error of negative 5 over 4. Okay, I mean the static error constant or position constant as 5 over 4. Okay, now, the steady state error is then, this is, okay, the steady state error is then 1 over 1 plus Kp, which gives you negative 4 as your steady state error. Okay, now, ano yung sinasabi nung negative 4 na, na error? Okay, it means na dumadagdag again as discussed in the previous lesson. Yung error na negative means this adds up dun sa ninyo. Dun sa input ninyo. Okay, and therefore the final value of your output is then the absolute value the input plus the absolute value of this. Okay. So, yun. The negative value for the steady state error implies that the output step is larger than the input step. Okay? Okay. So, let us demonstrate yung paggamit ng Simulink para ma-simulate natin tong system na to. Okay. So, you can, kung may MATLAB na kayo at may kasama siyang Simulink. Okay. You can start Simulink by this one. Tapos may lalabas na screen dyan which allows you to open blank model or create a blank model. So, piliin nyo lang yun. What would happen is, this would come out. Okay. So, ngayon, maglalagay tayo ng blocks ninyo which represent transfer function. Pero again, katulad nung yung pag-express nyo ng transfer function sa MATLAB, you can express also your transfer function sa Simulink using yung transfer function manner. Okay, o yung ibig sabihin yung naka-polynomial form siya. Okay, o kaya pwede rin naman siyang zero Polkin. Okay, o ZPK. Now in this case kasi mas madaling gamitin dito yung ZPK. Okay, so let's use the ZPK. Okay, now you can put in some systems here, okay, by using this library browser. Pero if you're using version 2018 pataas ng MATLAB o ng Simulink, mas madali na siya by actually typing here. So click nyo lang dito sa white field, okay, and then type nyo lang, for example, 0 pole gain. Okay, so lalabas na dyan yung mga options. Okay, so let's use 0 pole. Okay, so ito yung lalabas. So medyo palakihin natin ng konti. Ayan. Okay. And then double click natin siya para mabago natin yung yung nasa loob. Okay. So it would ask you to enter parameters such as zeros, pole, and gate. Okay. So for that we will key in, okay? Wala tayong lalagay na 0, okay? Pero yung gain i-add natin sa 100. Okay? That would have been more realistic sa ano, kasi wala naman talagang zero tong system niyo. Okay. Pero meron siyang gain na 100. Okay. So, ngayon, yung poles natin ay nasa origin. Nasa origin siya para dun sa factor na S. Okay. Tapos yung isa, nasa negative 10. Okay. Para dun sa S plus 10 na factor. Okay. So, let's apply that one. Okay. So, we will see na yung transfer function natin or yung ating zero pole gain becomes this one. So, ito yung ano, nasa given natin. Ito. Okay. So, press OK. And then, para sa feedback, duplicate natin to. So, to duplicate this, click nyo lang siya, then press Control, okay, and then drag pababa or somewhere. Okay, para ma-duplicate nyo siya. Okay, and then release. So, ngayon, una, i-flip natin ito. Okay. So, right-click natin siya. And then, rotate and flip. Tapos, flip natin yung block. Para yung direction ng signal nyo, paano? Ito yung input, ito yung output. Instead na ito yung input, ito yung output. Kasi nga feedback siya. Okay. Now, next, let's insert as, pagbuhin pa natin yung transfer function nito. So, yung transfer function to is basically 1 over S plus 5. Okay. So, again, let us double-click this one. Wala tayong lalagay na 0. Yung gain, i-adjust natin sa 1. Okay. Tapos, yung pole natin, meron lang tayong pole sa negative 5. Okay. So, ayan, negative 5. Yan lang yung pole natin. So, apply. We verify na ito yung magiging transfer function. So, okay. Okay. Now, next, let us put in a summing junction. So, again, click kayo sa wide field. Sum. Search natin yung sum. Okay. So, ito yun. Kailangan natin. Okay. So, ito siya. Medyo palaki natin ng konti. Oops. So, ayan. Okay. Then, double-click natin siya kasi gusto natin palitan na yung signal nyo dito is negative. Kasi currently, naka-positive siya. Okay. So, pwede kayo maglagay ng multiple inputs dito sa summing junction ninyo. Okay. Kaya lang, kung gusto nyo wala, halimbawa, ito, dalawa lang. Okay. Naglagay siya ng dalawang symbol. So, ito, yung straight line ninyo. Okay, ito yung in my version ng keyboard. Ito yung nasa taas yung shift tas yung key na nasa taas ng backslash. Okay? So, yan yung character na yun. Tapos plus plus. Okay, so yung unang plus na ito actually pertains to yung sign nung nasa top nung summing junction. Okay, tapos itong middle, ito yung nandito. So, itong dulo na to represents yung sign na nasa pinakailalim. Okay, so gawin natin negative yan. Okay, and then apply natin. Okay, so makikita nyo, mag-a-adjust ngayon sa minus siya. So, that satisfies yung requirement natin for a negative feedback. Okay. So, now, let us simply connect yung mga kailangan natin connect dito. Like, for example, ito. Okay, yung output ng summing junction nyo. Click lang to. Connect natin siya dun sa input ng G ninyo. This is G. Okay, lagyan pala natin label, no? So, bago tayo mag-connect, lagyan natin label. So, again, click nyo lang doon sa white space, then type nyo lang G, S. Okay. So, pag wala naman siya makikita ang component, isasuggest niya sa inyo na to create the annotation. So, just click on that. So, nag-create na kayo ng annotation ng G of S. So, alam nyo na ngayon, G of S yan. Okay. And then, let's also create the same here. Okay, so this is H of S. Okay. So, ayan. So, yun. Now, let's connect yung output ng summing junction niyo. Okay, so click dun sa output. Okay, and then click nyo lang yung input ng G. Hindi na kailangan i-drag. Basta click lang yung output, click sa input. Okay. So, ayun. Again, click natin yung output nitong HS. Okay, papunta doon sa input ng summing junction. Okay, and then ito, click natin dito. Adjust na natin ito dito para medyo may konti niya. Okay, now, to complete this, kailangan natin maglagay ng input signal dito. Okay, so since yung input signal natin is a step, we will have yung input signal niyo as a step signal. Okay, so we will input in step. Okay, so ayan. Galing yan sa sources. Okay, so connect lang natin siya and then para mabago niyo yung parameters niyan, natin siya, double click natin siya. So yung step time nito, it means kung kailan siya magsi-switch from 0 to 1. Okay, so or from the initial value to final value. So yung step time nito, ibig sabihin at 1 second, doon siya magpapalit ng ano. So medyo iklian lang natin siya. Gagawin natin 0.5. Okay, tapos ang initial value natin is 0, ang final value natin is 1. Okay, so apply natin yan. And this is your RS. Okay. This should be your RS. Now, para ma-measure natin yung output ngayon, okay, let's, and take note that this is your, this should have been the actuating signal. Pero since i-assume nga natin na yung R nyo tsaka yung C niyo have the same units, so we'll call it E of S instead, itong signal na to. Okay. So, yung output naman natin can be, measured using a scope. Okay. So, type natin scope. Okay, which is found on the sinks library. Okay, so connect natin siya dito. Okay, and then later on, kapag tapos simulation natin, we can simply click on this one. Okay, and then makikita natin yung graph. Ito nung nakita nyo earlier sa naunang video. Okay, so ayan. Now, pwede tayong gumawa ng adjustment sa sa simulation simulation, how your simulation should be done. Okay. Pero normally isa sa gusto nating palitan is yung simulation time, yung haba ng simulation time niya. So in this case, nakaset natin after 10 seconds hihinto na yung simulation niya. Okay. So later on, kapag medyo nakita natin na masyadong mahaba to for your system, let us shorten this one. Okay. Pero initially, I'll determine kung okay lang ba yung 10 seconds o kailangan nating iklian or kailangan nating habaan. Okay, so irarun natin to. Okay, so nagrun na yung simulation. So what we need to do next is to double click this scope. Okay, para makita natin yung CS niyo. That's why nilabel natin ito ng C of S. Okay, so double click natin siya. So it results to this graph. Okay, so it seems na masyadong mahaba yung 10 seconds. So possibly mga between 5 and 6 seconds nagsettle na yung system niyo. So let's just set the end of the simulation time at 6 seconds. Tapos run ulit natin. So there. Okay. And if you're wondering kung bakit medyo pinopost ko yung video pagkatapos pag nagda-run ako, medyo hindi kaya ng computer ko na pagsabayin yung simulation tsaka yung video recording. So para hindi mag-crash yung ayan. Pinopost ko yung recording para mag-idea ako mag-run. Okay, pero sa totoo lang, medyo matagal itong simulating. Kaya kailangan niyo lang siya talagang tiyagain na hintayin. Pero after naman na naka-load na yung mga models and everything, and okay na yung settings niyo, mas na yung performance niya, mas mabilis na yung performance niya. Okay. So, in this case, we have this output. Okay. So, take note ang signal niyo is step input. Okay. So, ibig sabihin nun, ang final value ng signal niyo is basically 1. Okay. We could also have added it pala dito sa waveform natin. Okay. Para magawa natin 'yun, let's cut this one off first. Tapos gamit tayo ng multiplexer. Okay. So, search lang natin max MUX. Okay. So, ito 'yun, yung signal routing. Okay. So, we have this. Tapos kailangan natin dalawang input para sa ating multiplexer. Okay, yung first input natin, kunin natin galing sa RS. Okay, so galing dito, connect natin sila. Okay, taas natin ng konti ito. So this signal is your RS. Okay, tapos yung second input ng ating multiplexer, connect natin sa CS. Para ma-compare natin yung CS tsaka yung RS. Okay, tapos connect natin siya sa Okay, tapos run natin siya ulit. Okay. So that results to this kind of plot. Okay. So makikita nyo ngayon na yung input niyo is the yellow waveform, while yung blue is yung output niyo. This is your RS, this is your CS. Okay. Ngayon makikita nyo na again mas mataas yung output sa input. Yung difference na to. Okay, let's put in some cursor measurements. So we have opened this, okay. Yung ito as your cursor measurement. Okay. So in this case may mga options siya ngayon dito. Okay. what we will do is dito sa ano sa cursor measurement, okay, sa na settings, yung waveform cursors nyo, since dalawa yung mini-measure na waveform niya, you can set the first waveform, itong may label na number 1, okay, to measure the step input. Okay, that means yung RS ninyo. Okay, and then pwede nyo iset itong second to measure the zero pole. Okay, which means yung measure yung after nung una yung zero pole system. So that measures your CS. Okay, so ayan. Now, what we do, okay, is then ilagay na sila sa approximately at the same time. Okay? Lagay natin silang dalawa sa parehong time instant. Okay, so that we can see yung value nung waveform 2 na 5, yung blue niyo, that is 5.004. Okay? And then yung niyo, yung value or yung value nung waveform 1 niyo, okay, which is 1. Okay, so ngayon yung gap na yan between this and this is yung error niyo. And again, remember, error is input minus output. So yung value ng input niyo is 1, yung value ng output niyo is 5. So 1 minus 4 is negative 4. Okay. So yung again, yung implication na negative yung error niyo, it means na yung output niyo is higher than the input. Okay. It implies na yung output niyo is higher than the input. Okay, and then yung gap na yon is there. It's the absolute value. So that verifies yung computation natin. Okay, na yung error ninyo is negative 4. Okay, so we have computed here na yung error ninyo is negative 4. Okay. Now, we then continue our lesson by moving on sa system na meron ng non-unity feedback. Okay, meron na siyang non-unity feedback. Meron pa siyang disturbance input. Okay, so in this case, we will have to say na again, ang assumption dito is yung R niyo at yung C niyo are of the same quantity and therefore have the same dimensions. Then we can compute the steady state error in terms of this one. Okay, so again, this follows from the superposition theorem, okay, in which ito yung component ng ninyo, o ito yung output niyo due to R when we set d equals 0. Okay, and then this is your component, okay, when we due to d, okay, when we set R equals 0. So i-add lang natin sila. Okay, and then assuming that the system or the poles or the poles, the roots of 1 plus g1, g2, h1 or h are in the left half plane. Okay, then we can apply the final value theorem as what is 6.24 is demonstrating. Now, if we assume that we have step input and step disturbances, yung steady state error ninyo due to the step inputs and disturbance, okay, would become this one. Okay, so ngayon, para maging 0 yung steady state error nyo, overall na to para maging 0 yung ninyo, yung error ninyo, okay, we will have this term, okay, we will have yung term na to, okay, dapat mag-equal itong term na to, dapat mag-equal yan sa 1 para 1 minus 1, 0. Okay, and at the same time, dapat itong term na to, dapat mag-0 yan. So para maging 1 minus 1 minus 0, 0 yung steady state error natin. Okay, and how will that happen? Okay, verify nyo, okay, please verify, okay, na para mangyari yun, para maging 1 ito at maging 0 ito at the same time, you should have your system to be stable. Again, para maging stable siya, yung poles ng 1 plus G1, G2, H should all be in the left half plane. Okay? So, yung poles nito should be on the left half plane. On a left half plane. Okay? G1 should be a type 1 system. Okay? G2 should be a type 0 system. Okay? And H is a type 0 system whose DC gain is unity. Okay, so kailangan ma-satisfy yung apat na yan. Now, I would like you to verify this verify on your own these requirements. Okay, para ma-verify natin na or para malaman natin na magiging 1 nga ito at magiging 0 nga ito. Okay? So just use example systems na type 1 tsaka type 0. Okay? And type 0 para sa H, okay? Na ang BCK niya ay unity. Okay, that is kapag kinompute niyo yung limit ng H as S approaches 0, dapat ang sagot diyan 1. Okay? So probably ang example niyan is 1 over S plus 5. I mean 5 over S plus 5. Okay, mali pala. Okay, 5 over S plus 5. So bakit kaya naging bakit ito satisfies yung number 4? Okay, again, pag kinompute niyo yung limit nito as S approaches 0, that becomes 5 over 5 or 1. Okay, so dapat ganyan yung makita natin. Okay, so verify by using particular examples para sa G1, G2 at saka sa H. Okay, kung tama na magsisiro yung error niya. Okay, so that is the error. Okay, that is how we will reduce the error of your system to 0 kapag meron kang disturbance and meron kang non-unity feedback system. Okay, or meron kang non-unity feedback. Okay, and then finally, we now talk about yung actuating signal itself. Okay, so kanina, ang pinag-uusapan natin is puro error. Okay, and we are under the assumption na yung R ninyo, yung input ninyo, tsaka yung output ninyo, again, are of the same quantities and therefore would possess the same dimensions. Now, in this case, if we remove that restriction or if we remove that assumption, okay, so we shall say na yung R ninyo and C are now of different quantities and therefore have different units. Okay? So, the actuating signal then is computed as this limit or as this expression. Okay? Kapag ang assumption is that C and R are not of the same quantity. Okay. So, let us work on example 6.13. Pero kung tatandaan nyo, ito rin yung nasa 6.12 na example. Okay. Pero this time, kasi sa 6.12, ang may assumption doon na yung R at saka yung C are of the same units or of the same quantities. Okay. Pero this time, in example 6.13, wala na yung assumption na yan. Okay. So, in that case, we will have to compute EA. Okay. As using this formula. Okay. So, and we take note that ang R natin is R of S natin, okay, is 1 over S. Okay. So, in that case, we will have, or when we substitute now, we will have, ang G1 natin is basically yung input transducer. Okay. So, again, nagsisimula yan dito sa form na to. This is G1. Okay. Yeah, that is G1. Tapos ito ay G2. This is your H1. Okay. So, now, from there, we should see na yung G1 ninyo is basically 1. 1 siya dito. Okay, kasi wala diretso yung signal nyo to, so you have a unity transfer function for your input transducer. Tapos ang G2 natin is itong forward transfer function, which is 100 over S times S plus 10. Okay. And then yung H1 natin is basically 1 over S plus 5. So when we substitute these things dun sa ating 6.26, you would have this. Okay, so S times R is 1 over S times 1 for your G1 over 1 plus 100 time over S times S plus 10, that's your G2, times 1 over S plus 5, that's your H1. Okay, so we first divide this two, okay, para maging 1 sila sa numerator. Tapos tsaka tayo mag-compute ng ng limit. Okay. But when we compute the limit, we take note na meron tong integration factor dito. Okay? So, when we now compute the limit, magzi-zero tong denominator nito. Okay? So, kung nag-0 yung denominator nito, this factor becomes an infinite number. Okay, so therefore, this entire denominator becomes an infinite number. So, 1 over a very large number is 0. So, in this case, yung error ninyo, yung actuating signal ninyo, okay, has a value of 0. Okay, for this given system. Okay. Now, that would change kung ang input na i-consider natin is ramp. Okay. So, if you have a ramp, system, okay, what would happen is that, ito yung S, okay, galing sa formula. Again, the formula is S times R times G1 over 1 plus G2 H1. That's the formula. Okay. So, tama di ba? Yeah. So, what would happen is, that's S, tapos 1 over S square, tapos times 1, that's for G1. Ito, 1 plus, this is your G2, and this is your H1. Okay. Now, what would happen is, kapag kinancel natin ito, may iiwan na isang factor dito, which is then multiplied here. Okay. So, ang mangyayari dyan, magiging ganito. That becomes the limit of 1, okay. Tapos yung S na naiwan dito, i-multiply ko dun sa denominator. So, yung isa mamumultiply dito, that's S. Tapos plus, yung isa mamumultiply sa factors na to. Sa dalawang factors na to. So, yung S na mamumultiply dito, I would use that to eliminate this S here. So, yung S dito tsaka yung S dito would actually be divided to each other. So, magiging 1 na sila. So, may iwan ngayon doon sa second term ninyo is are the factors 100 over S plus 10, okay, times 1 over S plus 5. Now, we evaluate that limit as S approaches 0. Okay? So, now, kapag in-evaluate natin yung limit, we will have 1 over 0 plus 100 over 10 times 1 over 5. Okay? So, yan ay magiging 1 over, yung 100 over 10 is 10 times 1/5. That's 2. Okay, so magiging 0 plus 2 yan. So, that becomes 2. So, ngayon, yung actuating signal natin for that becomes 1/2. Okay? So, you may want to verify that with the simulation. Okay? Pero what would happen is, we have to make sure na magkaiba nga yung units nila. Okay. So, simulation pala assumes that your signals are of the same quantity. Kasi nga, yung ating, yung ating summing junction just works on the principle na yung signal dito minus yung signal dito is the output. So, under that, you would be assuming na na pareho nga sila. Okay, pero we need to find a way para mas makapag tayo ng actuating signal or makapag-simulate tayo at makapag-measure tayo ng actuating signal through simulation. Okay? So, ayun. Now, what I would like you to do then is to try to work on example 6.14 on your own. Okay, para magamit niyo yung formula. Pero take note na pareho lang yung results. Okay. Pero sa una kasi pinapahanap yung error. Okay. Sa pangalawa, pinapahanap actuating signal. Pero fortunately, what would happen is that pareho yung results nila. So please verify na pareho nga talaga. Okay. By using the appropriate formulas. Okay. So para sa letter A, you would have to reduce this to an equivalent transfer function. Okay. Na G over 1 plus GH minus G. Okay. And since wala naman kayong 1 naman yung transfer function nyo nung one naman yung transfer function ng input transducer nyo, that makes it G equals G2, which is 100 over S plus 4. Tapos yung H niyo is H1 simply. Okay, which is 1 over S plus 1. So, ayun. Work on this. Then, makikita nyo na ito yung error niya. For letter B naman, gagamitin natin yung formula na EA, okay, equals SR times G1 over 1 plus G2 H1. Okay. So, and by the way, I think I had a question sa inyong homework. Isa sa mga questions sa homework ko pala na alala ko. asking you to derive yung 6.26. Okay, so ito yun. Yung equation 6.26 is basically ito. Yan. That's your equation 6.26. So, yan yung nasa homework niyo. You will be asked to derive this equation. Okay, so please do find a way para malaman nyo kung paano yung derivation to. Para malaman nyo rin kung paano kumuha ng actuating signal. Okay. So, and then, again, work on example 6.14 on your own so that ma-practice nyo yung paggamit ng mga formula.